Okay, factorising quadratics via grouping this time. Okay, so I've got a bunch of stuff here just to make a point so that we don't have to do it slowly. Cool, I've got these two things, I've just expanded them. So x and a, I've just written it in alphabetical order, ax, x by b, bx, a by y, b by y. Cool, okay. Great. I'm hoping that we're happy that this expands to that. I'm also happy that if I switch the order of the brackets, that's the same. As in a times b is the same as b times a. If you flip the order, multiplying doesn't matter in the number system. Great. And so if I expand that, I get this. Great. Should also hold that if I just shift these across and put that one at the end, that should be the same since they're all adding together. And similarly, if I switch the order of these two, leave that one alone and just shift this down, they should all be equal. So all of these things are just different ways of writing the same thing. Why have I done that? We'll come back to that later. Okie dokie. So I've got this thing. Great. Is this a quadratic? Alright, well, I've got an x squared and that's the highest power. So yeah, this thing is a quadratic. Okay. Well, this is a little bit weird because now we've got 4 terms instead of 3 terms, or even 2 terms for the difference of 2 squares. This is what grouping is for. It's for when you've got 4 terms typically. Okay, what are we going to do? Well, we're going to break this into groups, hence grouping. We're going to take the first two guys and take a look at them. X squared and 3x. Can I factorise that? Well, yeah, they've got an x in common. Alright, so I'll take an x out. So this becomes x plus 3. Hopefully we're happy that this bit goes to that bit. Cool, okay. Well, what if I look at the second pair? X, y, 3y. What have they got in common? They've got y in common. Okay, and it's a positive y, so positive is x plus 3. Brilliant. Okay, well, why did we do that? Well, conveniently, look at that. That seems a little bit weird. So I've got this guy and this guy are the same. Okay, so I'm now going to factorise this line. Well, these things are in common, so I can take out this entire set of brackets out the front. So this is in common, and I had x of them plus y of them. Beautiful. So I've ended up with a factorised version of this by doing it as 2 separate groups and then factorising those groups. Brilliant, okay? And as always, you can expand to check. So I've got x by x, x squared, x by y, xy, 3x, 3x, 3 by y, 3y. So yeah, when I expand this, I do get that version back, eventually. Cool, okay, well, what if I do it with this thing? Alright, let's do that then. Take a look at the first two. They've got x in common, okay? This 3 plus y, great. What have these got in common? Oh, nothing. Well, that's a little bit irritating. So this thing seems like I can't go anywhere. Alright, fine. Well, what if we look at this thing? Alright, I've got these two first guys. X by x plus y. Yes. Cool, these have a 3 in common. X plus y. Oh great, that worked. Because I've got the same thing in the brackets. Okay, so I'll take that common thing out the front, x plus y, multiply by, I've got x of them and 3 of them. Beautiful, okay. Well, let's try this one. They don't have anything in common. That's a bit weird. And these have an x in common, but I've already established that this doesn't have anything in common, so I don't know where to go from there. Alright, well, now if we take a look for a second, hang on, all of these have x squared, x squared, x squared, x squared, 3x, 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 xy, 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 3y, 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 3y. These are all the same thing, just in jumbled orders. So why did it work sometimes and not others? Well, I'm so glad you asked. It's almost as though I've set this up prior so that we had this to talk about. So these two guys are in blue, these two guys are in red. So what happened? Whenever you're trying to do grouping, you don't know which order it's been shuffled into. So it's very possible that you might end up in these two situations. That doesn't mean you can't do it, it just means you might need to shuffle the order. So how do you know when to shuffle the order? Typically you try to do it and you get one of those stuck problems, in which case shuffle out either of these two for either of those two. So for example, if we shifted this guy for this guy, we'd end up with 3x plus 3y plus xy plus x squared. Then we'd have, which one have we got? We've got an equivalent to that because these guys are those guys those two are those two. So we'd end up going down that path. And it doesn't matter which ones you pick, so long as you switch one of the first two with one of the second two. I'm going to switch this with this, just so we picked a different pairing. So I've got x squared plus now 3x plus 3y plus xy. Cool, x squared plus 3x is those guys. 3y and xy is those guys. So we'd end up back over here. So that's one thing that you've got to be slightly conscious of with grouping, is sometimes it won't immediately work, in which case flip. The way that I usually do it is flip the second and the third. You can flip other ones, it doesn't really matter that much, just so long as you don't keep these two the same. If you flip these two, nothing's going to change because they're still together. So you need to flip one of the second part with one of the first part. Doesn't matter which ones. It'll always work out in the end. Brilliant. Cool, so now we've got this. Alright, well, what have I got in common? First bit, I've got an x, which goes to x plus 2. Great. What have I got in common here? I've got y's in common, so x plus 2. Beautiful. Well, this guy and this guy are the same, so I take those out the front now. Cool, I've got x and y. Beautiful, we're done. You can expand it out to check that it all matches up. Okay, well, let's go down to this one. Alright, first thing, what have I got in common? Oh, I've got 2x in common this time. Alright, so I've got 2x in common with x and y. Cool. What have I got in common over here? Well, I've got negative 3, so negative 3 x plus y. Okay, great. Well, what have I got here? Oh, I've got the same thing in the first and the second. Now, it is possible that you didn't take the 2 out here, in which case you have 2x plus 2y. You must always fully factorise wherever you can. Otherwise, you'll end up with extra factors floating. Cool, these two are both out the front now. I have 2x of them minus 3 of them. Done, beautiful. Cool, going over to this guy. What's in common? All right, first two have x's in common. X minus y. Excuse me. Here, I don't have negative 5 in common, I've got positive 5 in common. Okay, so I've got a negative x and a positive y. Oh dear, well, that looks like we've stuffed up because these aren't the right match. So what can we do? Well, we can say, hang on, I could have taken out a negative 5 here if I wanted to. So what I'll do is I'll make this negative, make this positive, make this negative. Why have I done that? So that now all my signs match. Cool, so now we've got, great, these do match. So now I can take them out the front, x minus y, x minus 5. Beautiful. And as always, you can expand it out again to check that it works. Cool, next one, what's in common? Well, I've got a 4 in common and fully factorised, check. Oh, I've got x's in common, no y's in common. Alright, so this is 5x minus, 4's cancel, x cancels, y. What's in common here? I've got a 2 in common, so we'll keep it positive for now. 5x plus y. These didn't, oops, hang on, what have I done? Yes, yes. Ooh, something's wrong. 5, this is timesing by this, yes, yes. That's fine. How did I stuff this? Oh, this should be a negative 5, sorry. That's why. Okay, great. So these two, oh, the signs are around the wrong way, but we know how to deal with that now. Just make this the reverse sign and reverse all of these guys. Cool. All right, now this guy and this guy are the same, so we've got 5x minus y is the same, lots of 4x and minus 2. There's one other thing that you can do with this. This is true, however, if we look at it, oh, these have got a 2 in common. So what we can do is bring out a 2 all the way out the front. This doesn't change. This becomes 2x minus 1. Cool, so you're always looking for that common factor to bring out the front. Beautiful. Okay, now as always this last one is going to be problematic. So we're going to try to factorise this. Oh, that's okay, we've got an x out the front. X plus 3, beautiful, and we've got y's in common, good, okay. 4 plus y, oh dear, these don't match up. And we did factorise both of these. So that tells you that even if you shuffle this stuff around, it's not going to work out. So Sometimes this won't work for these kinds of things. For the ones in the book, unsurprisingly, it's setting ones that do work, but every so often you'll come across one that doesn't factorise at all. So don't expect that you will always be able to factorise these things per se, but for the ones in the book, it's set up so that they will always factorise. This is probably the least common form of factoring, simply because usually if you can do this, you can also do other things that you'll learn of as well. But for now, we're going to practice it because it's a good way to just practice your algebra and gives you an extra tool in the toolbox so that you can smash problems apart. Cool. Best of luck to you. Email if you get stuck. Cheerio.